All right, Mr. Gajewski here. Welcome back, everybody. 2.1.7. How can I write it? Simplifying and recording work. Today, you will continue to compare expressions as you strengthen your simplification strategies. At the same time, you will work with your class to find ways to record your work so that another student can follow your strategy. All right, 263. This is going to be done as a warm-up. If you are watching the video, I want you to do these on your own. You do not have to show your work. Or if you're not watching the video, you can follow along with us as we do what's called a hot potato activity in class. All right. After you're done doing this warm up here, if you're watching the video, let's go ahead. Let's talk about 264 together. Recording your work, although using algebra tiles can make some things easier because you can see and touch the math, it can be difficult to remember what you did to solve a problem unless you take good notes. Use the simplification strategies you have learned to determine which expression on the expression comparison map at right is greater. Record each step as instructed by your teacher. Also record the simplified expression that remains after each move. This will be a written record of how you solved this problem. Discuss with your team what the best way is to record your moves. Explore using the 264 tool. So I'm going to go ahead and I'm going to click that. All right. So I do want you to record your work here. So again, just to review there, write what you see, make a move, write what you see, make a move until you have completely simplified the expression on both sides. You can pause the video and try this on your own at this time, and then check back in with me as I work through it. All right, everybody, welcome back here. So let's go ahead and let's take a look. What do I see here? Well, I see 1 minus 2x minus 3. So that's up in the plus region. Okay, down below in the minus region, I see a minus 3. And actually, I'm going to put this in parentheses, the whole minus region, minus a negative x. All right. And then on the right side, I see a 2 minus 3 minus, now I'm looking at the minus region, minus an x minus a negative 2. Okay, the first move I'm going to make is I'm going to flip everything. Right there will work. And I'm going to flip here. So really what I'm doing is I'm distributing this negative sign. All right, the minus positive 3 became plus a negative 3. And the minus an x became a plus x. Same thing over here, 2 minus 3, the positive x became plus a negative x, and the minus a negative 2 became plus 2. Okay, go ahead and combine like terms, aka make zeros. Let's see, 1, 2. All right, when I go ahead and do that, right, the 2x, negative 2x plus an x leaves me with a negative x, and then a minus 5, right? 1 minus 3 plus a negative 3 is a negative 5, right? And on the right-hand side, I have a negative x. There's nothing I can combine that with. And then 2 minus 3 plus 2, right? 2 minus 3 is negative 1, plus 2, I get 1. Okay, so the question here then, oh, am I done? No, actually I'm not done yet. Let's go ahead and remove a negative x from both sides. Okay, now I have negative 5 and 1, which is greater. It's going to be the right-hand side. 1 is greater than negative 5. All right, so again, that is going through writing the expression and showing my work. I'm going to go ahead and clear. Let's jump back. All right, 265, let's talk about that together. While Athena was comparing the expressions shown at right, she was called out of the classroom when her teammates needed help. They looked at her paper and saw the work shown below. Unfortunately, She had forgotten to explain her simplification steps. Can you help them figure out what Athena did to get each new set of expressions? Explore using the 265E tool. We're not going to do that. All right, but let's go ahead and let's work through this together. So a little bit of working backwards here. We're trying to figure out what she did to help us get a better understanding of what those legal moves actually do. All right, what do they actually mean? So I'm going to go ahead and I'm going to read, all right, the left expression. How do I get from there to here? So what's the difference? Well, I see a 3x. I see the plus 4 minus x and a minus x. All right. Minus a negative 2. Yep, minus a negative 2. All right, plus x squared. The plus x squared is gone. All right, let's check the other side. I still have the minus 1s. The x squared is gone. So the 4x and then minus 4x plus 2, minus 4x plus 2. Yeah, that's still there. So what did they do? All right, she removed x squared from each side. All right, if I look at the next one here, still have a 3x plus 4 minus x, right? But the minus a negative 2, we flipped that to a plus 2. Right? Minus 4 gets flipped to a negative 4. Minus 2x gets flipped to a negative 2x. So she flipped the minus region. So when we flip from the minus region up into the positive region, that's what we're doing. It's like distributing that negative sign when we have parentheses. All right, we can take the 3x and the minus x to get 2x, the 4 plus 2 to get 6. What did we do there? We combined like terms. In other words, she made the zeros. Is there an E, 2 E's and zeros? I don't know. Not an ELA teacher. So let's reiterate that. So 4x, right? X and x, those go together. Negative 1 minus 4, or negative 1 plus a negative 4, I get negative 5. Okay, and then one last step. We still have the 6, we still have the negative 5, but we removed 2x from each side. So which side's greater? We're going to say the left. Why the left? Because 6 is greater than negative 5. All right. I'll give you a couple seconds to let that sink in. If you missed that, just rewind it. All right, let's take a look at 266. All right, for each pair of expressions below, determine which is greater, carefully recording your steps as you go. If you cannot tell which expression is greater, state not enough information. Make sure that you record your result after each type of simplification. For example, if you flip all of the tiles from the minus region to the plus region, record the resulting expression and indicate what you did using either words or symbols. Okay? Be ready to share your work with the class. So if you are working virtually and you are working synchronously with a friend, you can do a pairs check with them on these problems. Otherwise, the answers are posted on Google Classroom. There's an attachment there, 2.1 point, I believe this is 7, 2-66. All right, there will be a key there. Okay, in terms of recording your work and explaining, all right, again, write what you see, make a move, and now I want you to tell me what that move was. All right, so I'm going to add another thing in there. Now, if you're working virtually, all right, let's do this. I want you to do A because you have the E tool. I want you to do B because that's the E tool. C and D, those are going to be optional. Your homework starts at 266. We're going to go all the way to the end, 271. And I'm going to talk real quickly about 268. So on 268, read the math notes boxes in this lesson. So for this, okay, and for lesson 2.1.5, so you're going to have to go back a little bit. All right, that is going to tell you what we want to write here. So I'll do the first one with you. All right, here's my original expression. Here's my next one. So what changed here? All right, 3x plus 8 plus x plus 10. So I didn't really change anything, but I moved the parentheses around. So it means I'm going to be doing these in a different order. Now, even though I'm doing this in a different order, I'm still going to get the same answer. So what is that called? All right, well, if you notice here, I'm adding all of those terms together. So that is what's known as the associative property of addition. All right, the associative property of addition means that when adding three or more numbers or terms together, grouping is not important. So the order does not matter when we're adding. And here's an example, right? If I add A and then B and then C, it's the same as adding B and C first and then adding A next. You can take a look at it here. Right? 5 plus 2 is 7. Plus 6, we get 13. 2 plus 6 is 8. 5 plus 8 is 13. You can see there that the order does not matter. So down below on your homework, for that first one, we're going to say associative property of addition. So copy this table, and then we're going to write associative property of addition. All right, do the same for parts B and C. That is it for today. Thank you for watching. I'll see you next time.